said already, this talk will be a bit technical about networking in Kubernetes. And concretely, I'll talk about IPv6 and dual stack. Before that, let me introduce myself. My name is Rastislav Szabo. I'm software engineer at Kubermatic. I'm specialized in Kubernetes networking. I've contributed to several open source projects, right now mostly Kubermatic Kubernetes platform, but also others in the past. Apart from my professional life, I'm also a dad of 3-year-old boy, and I'm occasional orienteering athlete and orienteering race organizer. But let me go to our agenda for today. I would like to start with some introduction of IPv6 and why it is even needed. Then I would like to introduce dual stack networking. Then I would like to describe the state of IPv6 and dual stack in Kubernetes. Next, I would like to show you how to enable dual stack in Kubernetes clusters. And at the end of the presentation, I would like to go over the state of IPv6 and dual stack support across different cloud providers so that you can decide which one would work for you. And at the very end of this talk, I would like to show you a very short demo of a dual stack clusters in Kubermatic Kubernetes platform. So before IPv6, let me first talk about IPv4. Because it's still the core networking protocol that we use nowadays in today's internet. IPv4, or Internet Protocol version 4, was standardized back in 1981, so like 40 years ago, and we still use it. Essentially, it is used to transfer pieces of data that we call packets over the internet. And whenever the packets are transferred over the internet, they need to have sender and receiver address that we call IP address. And the IP address in IPv4 is a 32-bit integer value. We use dot decimal notation for IPv4 addresses. So an example is like 192.0.2.235. And one of the problems with IPv6 is that the 2 to the power of 32 gives us only about 4 billion possible addresses. Which is less than the current world population. So obviously, it is not enough for the demands that we have right now, where everybody is using multiple internet-connected devices. So not every device can have its own IP address. And because of this, IP addresses are actually quite expensive also nowadays. If you wanted to buy a larger chunk of IP address pool, you would need to pay a lot, and maybe it wouldn't be even possible for your ISP provider. The workaround that we are applying to this problem is called network address translation, which can hide multiple users or devices behind single IP address. This workaround has been working for quite a long time, but it brings a lot of complexity and many limitations that we would like to avoid. So the possible solution to the IP address space problem is IPv6, new Internet Protocol version 6, which is actually also quite old. It has been drafted in 1998, but the adoption still did not happen, so it's in progress. The biggest benefit of it is that it uses larger address space. So the IPv6 address is 128-bit integer value. And 2 to the power of 128 gives us many IPv6 addresses. So every single device that would connect to internet can actually have its own IPv6 address. And we don't even need to reuse them. We use hexadecimal notation for IPv6 addresses, 8 groups of 16 bits. Separated by colons. Some examples you can see. The IP addresses with 2001 are the same. There are some simplification rules that can apply. And bet colon cafe 2 colons is also a valid IPv6 address. The biggest benefit of this large address space is that we don't need to use network address translation. One of the biggest, or one nice things about IPv6 is that IPv4 can be transported or tunneled through IPv6 network. And thanks to that, the adoption actually started quite early by telco and internet service providers. Nowadays, most of the core networks of those are running usually on IPv6, and especially that's especially true for mobile networks and 5G mobile networks. Apart from larger address space, there are some more benefits of IPv6. First, the routing is a bit more efficient. First, because the network address translation is not needed anymore, so that itself gives us a lot of simplification. Then there is also no checksum calculation on each hop. On their part, IP fragmentation is not allowed by design. There are some more advanced security features built in. IPsec is natively built into the protocol with the fact that each endpoint has its own uniquely identifiable public IP address. Also means that we have end-to-end transparency. And one of the drawbacks from the security perspective is that with IPv4, with network address translation everywhere, network address translation actually acted as a firewall, kind of. So with IPv6, if every single endpoint has its public IPv6 address, it has some security considerations. You need to make sure that your firewall rules are applied on all the places where you need them. There are many other features, like stateless address auto-configuration, something that can potentially replace DHCP in IPv6 network, IP address mobility, which we can reuse in mobile networks, extension headers, an extension mechanism that is built into the protocol and can be used for extending the protocol for further use cases. Now let me talk about dual stack networking. So dual stack is essentially a transition technology by supporting both IPv4 and IPv6 at the same time. It turned out that we cannot just turn off the IPv4 internet and start using IPv6 on a single day. So we need some kind of transition strategy. And dual stack essentially means that dual stack enabled devices support both protocols, both IPv4 and IPv6. They have both IPv4 and IPv6 addresses. And they can use either IPv4 or IPv6, depending on what is supported by the remote end we are communicating with. And the decision is usually made based on address family returned from DNS. So whenever I, as a client, if I'm accessing some, let's say, web service, I would use some domain name. There would be a DNS translation. I would get a DNS reply. If the DNS reply contains only IPv4 address, I would use IPv4 to connect to it. If it contained IPv6 address, I would use IPv6 to connect to that server. If that DNS reply contained both IPv4 and IPv6, which is most often the case in dual stack networks, then it's up to the operating system which one it would choose. Normally, IPv6 would be preferred by most modern operating systems. This picture shows the different places where dual stack needs to be supported to have end-to-end dual stack connectivity. So first, if you want to use it in your home network, your network needs to be set up to run on both IPv4 and IPv6. Your CPE, customer premises equipment from your ISP needs to support it. Then your ISP needs to support both IPv4 and IPv6. And eventually, the service provider of the service that you are trying to reach needs to be both IPv4 and IPv6 enabled. And if we are talking about Kubernetes, then we are basically looking at the right side of this picture. So on the right side, we have service providers that can potentially run on Kubernetes. If we enable dual stack there, then we have the right side of this picture solved. Thanks to the dual stack transition strategy, the IPv6 adoption is getting higher and higher. We are reaching about 40% of adoption. This slide actually, or this graph shows the percentage of users that access Google services over IPv6. So you can see on global rate, it is about 40%. But if we zoom in into Germany, for example, in Germany we are already over 63%. Now let me go to Kubernetes. IPv6 only Kubernetes clusters is something that has been supported actually for a long time, since Kubernetes 1.9. But IPv6 only clusters are not that useful because it means that ports and services can serve only IPv6 clients. So you cannot really serve both IPv4 and IPv6 at the same time. So their use case was kind of limited to special telco use cases or networking use cases. As of Kubernetes 1.23, we have a dual stack feature for Kubernetes generally available. And with dual stack enabled, every pod in a Kubernetes cluster has both IPv4 and IPv6 address. And every Kubernetes service can be either single stack or dual stack, depending on what you choose. So you have a flexibility to tell Kubernetes whether you want to expose a service on IPv4, IPv6, or both. In theory, each pod in your Kubernetes cluster can have public IPv6 address if you set up it that way. It doesn't have to, but it can. And what we use for load balancing between the services is, unfortunately, again, network address translation. The virtual IP address of a Kubernetes service would be destination network address translated to pod IPs, as we do in Kubernetes for IPv4. Now I would like to show you how dual stack can be enabled in your Kubernetes clusters. So first of all, you need to have worker nodes that have both IPv4 and IPv6 addresses. So that is something that needs to be supported by the cloud platform or the platform that you are using for bringing up your worker nodes. Then you need to configure different control plane components with both IPv4 and IPv6 addresses. So Kube API server needs to be configured with IPv4 and IPv6 service cluster range. Kube controller manager, the same for the service cluster IP range. Also cluster sider, which is actually the pod network that you are using, needs to be configured with both address siders. The same on kube proxy level, so you need to configure the pod network in kube proxy. And in kubelet, you either need to use cloud provider. In that case, the cloud control manager would take care of handling the IP addresses for worker nodes, or you need to specify node IPs, both IPv4 and IPv6 manually if you are doing it on your own. And last but not least, the CNIs needs to be CNI that you are using needs to be configured to use dual stack. Depending on the CNI that you are using, most of the time you need to configure the pod sider and service sider on CNI level as well. Okay, so once dual stack is enabled in your Kubernetes cluster, you should see the following when you try to describe the Kubernetes nodes. If you describe the nodes, you should see some IPv6 address as well as IPv4 address in the node's status. It can be internal or external IP, depending on the cloud platform that you are using, but the main idea is that you need to see IPv4 and IPv6 address at the same time. If you describe any pod, you would see it has one IP address in pod IP field, but actually two IP addresses in pod IPs slice, which would contain both IPv4 and IPv6. And if you describe a Kubernetes service, in case that it is dual stack, you would again see one IP address in service IP field, but multiple IP addresses in service IPs field. Going back to Kubernetes services, as I mentioned, you have full flexibility on how you expose your services. Since Kubernetes 1.21, each service spec has two new fields. One is called spec IP family policy. where you can tell Kubernetes whether you want that service to be single stack or dual stack. If it's dual stack, you can request it via prefer dual stack or require dual stack. At the end of the day, it works the same way. The only difference is whether or not you get an error if you deploy that service into single stack cluster. And via spec IP families, you can control the IP family that you want for, in case of single stack, or the order of IP families in case of dual stack service. The order is not that important. At the end of the day, again, it works the same way. The order just controls what you can see in the services IP field. The first one, right, is always used for the service IP. So that's what you see if you just do kubectl get service. OK, and to conclude the description, I would like to describe the current state of IPv6 and dual stack across some cloud providers. So let me start with the largest ones. In case of AWS, each VM can get an /128 IPv6 address from your VPC. The public IP addresses are provided by AWS, and you can also bring your own IPv6 address range if you want. The problem here is that the dual stack load balancer services are not supported by the Cloud Control Manager of AWS, but they are supported by a specific AWS load balancer controller. So you may need to use that one if you need to have proper ingress load balancing. In case of Microsoft Azure, it's a bit more interesting. The VNets and subnets would actually get private IPv6 address ranges. Also, the VM would get a private IPv6 address. And if you wanted to expose it to the internet, you can request a public IPv6 address, but internally it would work on the network address translation. So it would be, each packet would be destination network address translated to the private IPv6 address of the worker node. Similarly, the load balancer services are not yet supported by Azure Cloud Control Manager, but that is, I think, work in progress already, so it should come soon. And to conclude this slide, in case of Google Cloud, again, each VM can get a public IPv6 address. And again, the dual stack load balancer services are not yet supported. Here are some smaller cloud providers. For example, in case of Hetzner, you would get each VM would get a whole range of IPv6 addresses. Actually, each VM would get 2 to the power of 64 IPv6 addresses that you can use internally without within that VM. For example, to address the pods. The load balancer services are even supported, so that works in this case. There is a minor problem, but in general, very good IPv6 support. In case of Equinix Metal, each node gets an IPv6 address as well. And again, the problem with the load balancer services. And similar situation with the DigitalOcean, where each VM could get 6 IPv6 addresses, but there is a problem with load balancing. To finish this overview, I would go through some private cloud or on-premises providers. So in case of OpenStack, there is actually very good IPv6 support. There is a lot of flexibility. A lot of depends on how exactly you set up your platform. Public IPv6 CIDRs can be allocated via features called subnet pools or prefix delegation. And dual stack load balancer services will be supported partially as of Kubernetes 1.25. I actually did the PR, which added that support. And in case of vSphere, actually everything depends on your setup. The load balancing is not being handled by vSphere Cloud Control Manager, but you can use the bare metal way of load balancing. And for that, we have the open source project called MetalLB, which already supports IPv6 load balancer services in layer 2 mode as well as in BGP mode. To summarize this, on the node level, IPv6 support is mostly supported across most of the platforms. but the ingress IPv6 load balancing is not that well supported at the moment. But on many platforms, this is already a work in progress, so it should come soon in the next Kubernetes releases. In case that it is not supported by your platform that you would choose, you can still use Node port to expose IPv6 services in the meantime. If you want, you can check out this link where we track the support of IPv6 dual stack across different cloud providers. So you are feel free to scan this QR code. It will guide you to our documentation. And now I would like to show you a short demo, if it works, of an dual stack Kubernetes cluster. With Kubermatic Kubernetes platform, you can actually request a dual stack cluster. This is the UI of the Kubermatic Kubernetes platform. If you want to deploy an IPv4 and IPv6 dual stack cluster, you just need to select an option here, and that's all you need to do. If you want, you can provide some more specific information, but it's not provided. Then we'll automatically deploy, all the control plane components in a proper way, and we'll automatically deploy the worker nodes in a proper way, so the dual stack works. But let me go to my console here. So here I have a dual stack cluster already running, and if I do kubectl get pods, output wide, you see that it looks like the pods have only IPv4 address. But if we describe them, kubectl describe pods, you may see that pod IP is just IPv4, but in this IPs field, we actually see both IPv4 and IPv6 address of that pod. I will start a new pod. And from this pod, we can try to access the pod that I just showed via IPv4 and IPv6. So let me just show you first the IP addresses that this new pod actually has. So as you can see, it has an IPv4 address, but it also has an IPv6 address. This one, scope global, is the one that is important. And now we can try to curl the pod that I showed before. So this one we can definitely do via IPv4, but we should also be able to curl it via IPv6. So this is the address. Yeah, so that works as well. Now let me go to services. So if I do kubectl get services, you may see here that some of them have look like they have IPv4, and some of them may look like they have only IPv6 cluster IP. But if we describe them, you will see why. So for example, this one is single stack IPv4, so it has only IPv4 address. This one is dual stack and has both IPv4 and IPv6 addresses. This one is dual stack as well, just the order of addresses is different. So the first one would be IPv6 that we showed in the previous example. And this one is single stack, but IP family is specified as IPv6 only, so it only has IPv6 address. And the last one is actually a load balancer service, which is dual stack, both IPv4 and IPv6. And you can see both IPv4 and IPv6 IPs here, but also in the load balancer ingress, we have both IPv6 and IPv4 address. Maybe the last thing that I would show would be, sorry, kubectl run. I will again run a new pod. And in this pod, I will try to NS lookup for this service. So I'm now resolving the service name to IP address of that service. And as you can see, I got two parts of the reply, and one is the IPv4 address, and one is the IPv6 address. So I can, again, use either one to access that service. So let me try IPv6 here. And just to have it complete, I will also try IPv4 one here. Oh. Right, so that worked as well. So yeah, that was my little demo here. I would conclude this presentation with saying that the dual stack feature is a new feature of our open source Kubermatic Kubernetes platform, version 2.21 that we released this week. So you can give it a try if you want. And apart from the dual stack support, there are many other interesting features that you can check if you scan this QR code that will guide you towards our release blog post. So that's it from me. In case of questions, I'm good to answer them.
All right, let's have a round of applause. Thank you. And we definitely have questions. We have lots of questions. So settle in. Yeah, let's feature this one. So do you have a good use case for enabling dual stack in Kubernetes?
Yeah. So I would say the main use case is to enable both. I mean, if you are providing some kind of service, let's say web service, by enabling dual stack, you can make it available via both IPv4 and IPv6. If you make it available via IPv6, your IPv6 users would have faster connection. There is an impact on the delay because of the faster processing that I described. Mm-hmm. And also, for example, if you need to certify your mobile application for certain platforms, they require such services to be available on IPv6 only networks.
Yeah, and I just highlighted this other question because I think it also answered that one, which was why do I need IPv6 within my cluster?
Right.
Or is there anything more that you would want to add to that?
No, I think it's answered. Yeah.
Great. All right, that one's been done. Is there a recommended way to disable IPv6 on pods? The dual stack control is only there for services.
Yeah, you cannot disable it. Once you enable dual stack, each pod has IPv4 and IPv6 address, but you don't have to use it if you don't want. If you just IPv4 services, you would be still using IPv4.
Okay. Then we've got why prefer the complexity of dual stack instead native, okay, IPv6,
yeah.
Only in combination with DNS64 and NAT64.
I would say the DNS 64 and NAT 64 is more complex than enabling dual stack in Kubernetes cluster, because if you enable it, you can have end-to-end IPv6 connectivity without network address translation.
So basically, you're saying the question is got it the wrong way around. There's actually more complexity
I would,
the other way, in your opinion.
Yeah, in my opinion, it's the other way.
Okay. Oh, here we go. How do you use a load balancer without NAT in IPv6 mode?
Yeah, that's a question for which we don't have the correct answer yet, but there are definitely more people thinking about how we can implement load balancing in IPv6 without the need for network address translation.
Is it just a bit of a hangover from IPv4, or is it?
Yeah, I mean, the way how it is implemented right now is via exactly the same way as it was in IPv4, because that's how it's implemented in kubeproxy.
Cool. Do all CNI providers support dual stack?
Not all, but the major ones do support that. So Cilium, Calico, Canal supports dual stack.
Okay. To completely move to IPv6, do we remove IPv4 in all configuration? And if we do that, can I assume that's IPv4 clients connect to such services?
Yeah, so the thing is that, exactly as I said at the beginning of my presentation, we had the IPv6 only support in Kubernetes for the long time. And because of serving only IPv6 clients, the use case was very limited. So dual stack actually allows that transition, but the transition still needs some time. And I think it will be years or even decades until we stop using IPv4 completely.
Which kind of answers this question. Is there a rough estimation as to when IPv4 will no longer be available?
Yeah. I don't think there is such an estimation yet, but I guess it will. I mean, we'll see how it goes with the adoption rate.
Yeah, next question, oh sorry, there we go. Is it possible to show IPv6 by default and not IPv4?
Yeah, so for both pods and services, it is possible if you switch around the order of IPv4 and IPv6 subnets that you pass to the control plane components.
Okay. Does DNS resolution for SVC also use the IP families order, or does it depend on the operating system?
Yeah, so the last one. Okay. So the DNS itself would return you both address families, and what you do with that answer from the DNS, it's up to the operating system.
Okay. And last question so far. How is the state of IPv6 with other components that you might need in a real-world setup, like CNIs, observability, mesh tools, etc.?
Yeah. So CNIs, I think I covered. The most used ones already support dual stack. For the things like observability, if they work on layer 7, they don't really care. So if you have components that just use HTTP, they do not really care about what is on the layer 3 of the networking stack. So in general, it works. I cannot say about service meshes. That ones I haven't tried myself, but I wouldn't expect any big issues.
Yeah. I mean, with the rate of adoption, I'm not surprised.
Yeah.
It's well integrated. Well, okay, thank you so much. Let's have another round of applause. And yeah, thank you.